All right, mathletes, here's A6, quadratic equations with complex solutions. First thing we're going to do is talk about some complex numbers. Make sure we're on the same page with that. Complex numbers have a real and imaginary part. The real part is typically written first. The imaginary part is followed. And the imaginary part is always identified by the I value. We should know that I comes from the square root of -1. It's a solution to x squared equals -1. If we square I squared, notice it's -1. I cubed, you can think of it as I times I squared. Well, that is just -I. And I to the fourth is the same thing as I squared times I squared, which is 1. So those will be a pattern as you increase those powers. So when we're adding and subtracting complex numbers, we just need to remember to add the reals and add the imaginary parts. So for example 1 here, to add these two complex numbers, I look at my real parts and I say 4 minus 3 is 1. And then I look at the imaginary parts, and 5i plus 2i is 7i. So that's adding complex numbers. Subtracting is very similar, but we got to remember to do our distribution of this -3 to the -3 and -4i. Sometimes I like to just write this out and treat it like an addition problem. So then I get 1 plus 6i plus -3 minus 4i. And I've already distributed that through. So my real parts, 1, -3, I get -2 is my real part. My imaginary part is 6i minus 4i, and I will get plus 2i. And there is my solution there. 3, when we're multiplying complex numbers, just like we do with linear products, we have to double distribute. So I have to multiply 6 to 3, and I get 18. I have to multiply 6 to I get plus 6i. I have to multiply -4i to 3, I get -12i. And then I have to multiply -4i to 1i, and I get -4i squared. I'm not done yet because I need to realize that this here, I squared, is not in the complex form. So I need to do a substitution. So I'm going to collect my like terms where I can. I get 18. And then plus 6i minus 12i is going to be a -6i. And then I have -4, and now I remember that I squared is equal to -1. So I do that substitution there. So -4 times a -1 is a +4. Collect my like term over here, and I get 18 plus 4 is 22 minus 6i. Now that is complex form, and I have multiplied my complex numbers. So in order to divide things, we have to talk about conjugates. Conjugates is just by switching our signs of our complex part. It's often denoted by the bar above it. Okay, so z bar can be written as a plus bi bar. Well, notice all we have to do for the conjugate is to switch the sign of our bi. So 4, if I take z, which is 1 plus 4i, and I want to find the product, meaning I'm going to multiply its conjugate. So its conjugate is 1 minus 4i. This should look familiar. This should look like our difference of squares. We have an addition here, we have a subtraction there. What's nice about this process is we're going to, by multiplying a complex number by its conjugate, it works out to be a real number. So when we're trying to rationalize denominators, that's going to help us out. So again, we have to, when we're doing products, we have to double distribute. So 1 times 1 is 1 minus 4i plus 4i. So just like with our difference of squares, our middle terms are going to cancel out. I got a minus 4i plus 4i. Then my last one, I get a minus 16i squared. Well, middle terms drop out. I get 1 minus 16i squared is negative 1. So this simplifies to 1 plus 16, and it's equal to 17. So that is the product of a z times z bar. We get a number that's no longer complex. It's a real number. So let's look at division here of complex number. If I want to write 1 divided by 2 minus 5i in standard form, okay, I need to multiply this by a form of 1. And that form of 1, I need to be strategical because I need to rationalize my denominator. I don't want a complex number. So I multiply by 1. Now 1 is going to be the conjugate of my denominator. So again, this is just 1. 1 times the numerator is just going to say 2 plus 5i. Denominator, double distribute. 2 times 2 is 4. Plus 10i minus 10i, and then minus 25i squared. I get 2 plus 5i in the top over 4 minus 25i squared is negative 1. So I get 4 plus 25 is 29 over 2 plus 5i. So I have divided that. Now, again, we have a similar one, but notice the numerator is also complex. So again, I'm still going to multiply. I'm worried about the denominator not being rational. So, or a rational real number. So I want to get my complex number out of my denominator. So I'm going to multiply by 1. And that 1, I got to be smart with the one I choose. So it's going to be 4 minus 3i. Change that middle sign. Then because it's 1, it's got to be the same as the numerator. Double distribute top and bottom. Okay, so we get 8 minus 6i minus 12i plus 9i squared all over 16 minus 12i plus 12i minus 9i squared. From there, I can collect my like terms, and I'm going to get 8 minus 18i plus 9 times negative 1 all over. Middle terms drop out, and I get 16 minus 9i squared, and I collect my like terms. I get 8 minus, well, I have 8 minus 9, so I'm going to get negative 1 minus 18i all over 16i squared is negative 1. So negative 1 times negative 9 is 9 plus 16 is 25. So there I have written it in standard form. So this is going to conclude the first part of this video talking about complex numbers. Part 2 will talk about how this ties in to solving quadratics.